Welcome to the mid-month math medley, or for short. Basically what I've decided I want to do in 2019 is make kind of like a newsletter, except a video in the middle of every month, and it's already 2/3 of the way through this month, so that's setting a good precedent for how things are gonna go. I really want people to know that maths is a living, breathing thing that's going on right now, and there's loads of cool things still happening in maths that you can get involved with, and there's loads of communities out there that I want you to know about. So here we are in January, and as happens every year, Chris Smith put out his usual countdown for the new year. Honestly, how does he come up with these things? So it's a new year, and we've got a new prime discovered by Patrick Larrick in Florida. It is a Mersenne prime discovered by the GIMPS program, the Great Internet Mersenne Prime Search. He uses the program as a stress test for computers that he's been building, and you could download this program and do it yourself and look for prime numbers. I'll leave the link in the description. So he managed to find a new Mersenne prime, which is 2 to the power of 82,589,933 minus 1, which is a huge number, like absolutely insane. 24,862,048 digits long. Can you imagine what it would take to write that out? It's more than 1.5 million digits longer than the previous prime number, which was also found in January last year. And just to put that in perspective, in true 2019 style, Simon Pampena has put together this infographic 10-year challenge of the largest prime that we knew in 2009 versus the largest prime that we know now in 2019. So in typical holiday fashion, my mum crocheted me not a jumper, but a poncho. And I've actually noticed some really cool things about this poncho. So it's made out of 16 equal-sized crochet squares. You'd think, oh, that makes sense. So if 16 squares, it'll be like a larger 4x4 square made out of it. Until you notice at the front, you've got this right angle corner here, and it's got the same at the back, but at the sides, there's actually no corner at all, which essentially means you're starting with two perpendicular lines that meet at a right angle here, and normally on a flat plane, two perpendicular lines, they would, cross each other and then just go their separate ways, kind of like a one-point stand, then they're never going to meet again. So what's happening here? We've got two perpendicular lines which go apart and then somehow come back to meet each other again. Well, the thing that's happening is you can't actually do this jumper here, this poncho, on a flat plane. You would only be able to do it in spherical geometry, and I will show you with a balloon. So we have a right angle here on my balloon, and if I just take this horizontal line and just extend it around, all the way around my balloon, and then if I take this vertical line here and I extend that around, so both of these are straight lines. I'm trying not to put any bends or corners in. And then on the other side, when they meet back up, were I a perfect robot at drawing, there's another right angle. So this is actually the shape of the poncho that my mum has made in spherical geometry. It's called a digon, and I really like it. And my mum says she's no good at maths. In some sad 2019 news, at the start of the month we lost Sir Michael Atiyah, who was a famous British Lebanese mathematician who did loads of really cool stuff to do with topology and different manifolds. So one of the things he looked at was how one circle in a cylinder could then become two, kind of like how on your leggings you've got basically one circle at the top, and then by the time you get down to the bottom it's become two circles, two cylinders. He was a really cool guy and contributed a lot to maths, and he recently did a lecture at the University of Edinburgh on the Riemann hypothesis. So I think in his honour we should all put on some leggings or trousers and watch his lecture. It's cool. I'll leave some links below. Some maths dates that we've had this month. If you are an American person or a kind of month first then the day person, then the 6th of January would have been Golden Ratio Day, so 1.6. Although since we've had 1.8 last year, it was kind of the golden year for it. And our approximation is just getting further and further out now, so really enjoy these golden ratio days while they kind of make sense. And on Golden Ratio Day, what you should do is you should try and convince someone that you can derive 5 from some weird, ridiculous natural place. So here's a bunch of photos of cactuses that I took. That's some low-hanging fruit. See what else you can come up with. In the usual UK date way, we will do Golden Ratio Day on the 1st of June. Yes, June. And on the 15th of January, which is the day I should have put this video out, we had Sofia Kowalewska Day. It celebrates her birthday, but it's also used to celebrate the wider contribution of women in maths. You're welcome. She laid a lot of the groundwork for partial derivatives, so maybe do a wee partial derivative in her honour. Upcoming future dates, we've got, for America, Euler Day coming up, celebrating the mathematical constant E. E wasn't discovered by Euler, it was discovered by a Swiss banker who was looking at compound interest. So I guess in celebration of E Day, you could calculate how much interest you're earning in your bank account. Or, if you're a millennial like me, you could just look at the beautiful mathematical equation e to the I pi plus 1 and remind yourself that that is how much interest you're earning on your savings. Apart from that, February is pretty quiet because all the mathematicians all across the land are getting ready for Pi Day in March. I think the best preparation that you could do for Pi Day right now is get yourself a pre-order of Matt Parker's Humble Pi book. I have a very well used copy of his previous book, Things to Make and Do in the Fourth Dimensions, which if you haven't read yet, is absolutely fantastic and is the reason I am so psyched for the next one coming out. I actually read this with my eyes on a page rather than having someone read it to me. That's how good this book is. Oh, also there's a full lunar eclipse tomorrow, the 21st, from about 2 in the morning till 7 in the morning, so you can have a look out for that if you are into the moon. And finally, I learnt there's something called a Sankaku puzzle, a traditional Japanese kind of puzzle where you usually just need to use Pythagoras and it's to do with circles and triangles, which was really cool for me because I'm trying to get my black belt in judo at the moment and Sankaku means something completely different in judo. So here's a Sankaku puzzle I found on r/mathriddles. The large quarter circle has a radius 6 and you have to try and find out the radius of the smaller semicircle and the little small circle there, the small circle. So hit me up on Twitter if you have an answer to that puzzle or if you've got any maths kind of news things that you think should be in next month's mid-month math medley. I'm gonna try and do this one for every month this year. I'll see how I get on, but please, you know, comment and all that and let me know what you'd like to see in this thing because I would like this to be kind of up-to-date, interactive current affairs of maths because maths is really cool and it's happening right now. I don't really have anything cool to say at the end of videos and I probably never will. I'm a jellyfish.